If you do not know what in the world I'm talking about when I do this real quick, then down here you can see Algebra 2 lesson 5.1. You can go back and learn how to do quadratic functions that are in vertex form. We're not going to worry about standard form of a quadratic. It's actually much easier to graph if it's vertex form. Or absolute value functions. If you're not sure about that, look back at the Algebra 2 lesson 3.2 lesson. They'll go over this in more detail if you're not sure. So how do we do this? We start with our vertex. We're going to go right 2 and up 1. And then from there, if you need, if you remember this, how to graph this with this 1, 3, 5 method, you can do that. If you have no idea what I'm talking about, then probably the easiest thing to do is to just use a quick little t-chart, XY t-chart, and plug in values that are close to the point we've already used. So we know that it's a positive 2, comma 1. Well, let's plug in x values that are close to that, 1 and 0. Plug in a 1, work this out, you're going to end up, it's a 2. If you plug in a 0, work this thing out, you're going to end up with a 5. So we're going to go over here to 1, 2, put a dot, and 0, 5. 1, 2, 3, 4, 5, and put a dot. And then since this is symmetrical, it reflects across the vertex, across this axis of symmetry. Okay, there is nice and curved on the bottom. There's a parabola. All right, so there's that quick review. Oops, I totally missed that point. Next one, absolute value. Same type of idea. We're going to shift left 3 because of the plus 3 inside. 1, 2, 3, and then up 2. And then because the front of this thing here is negative, it's going to be going down at a diagonal that direction and this direction. Okay, so again, more help for those on these lessons if you really don't know what's going on there. May have to have you go back for that. That is necessary for what we're doing today. Let's answer the question first, though. What in the world is a piecewise function? If you went through our Algebra 2 class last year, then this should be familiar, but some students, when we get to pre-calc, have not seen this before. This is the idea of a piecewise function. It is a function. That means it passes a vertical line test. You can't cross twice for a vertical line, and you're in pieces. This one has 3 pieces to it. So lots of times that means there's going to be a jump. Not always, but often there'll be some type of jump discontinuity going on with piecewise functions. So we're going to graph them and come up with equations and all that fun stuff. The first thing on our example, for example 1, is to see that these, what do we say this? This piece here, this negative x squared minus 2x plus 8, has a very specific domain. It only exists when x is less than or equal to negative 3. Okay, so every one of these pieces has its own domain, and this is where the domain is given. So I try to graph this just to kind of show you what a visual representation is of this. You don't have to graph these, but what we're doing is evaluating. We're going to plug in a negative 1. So the question is, which of these 3 pieces do we plug it into? We plug it in. Negative 1 is in between, it's this x value right there. It's in between negative 2 and 5, therefore we plug it into this. So we'll go 3 times negative 1 plus a negative 1 cubed, and you work this out, you get negative 3 minus 3, which, negative 3 minus 1, excuse me, negative 3 minus 1, which is a negative 4. Which, by the way, if I ever make a mistake and I write down the wrong answer, feel free to comment that below in the comments, because I hate having wrong answers up here and not finding out about it for a month. How about f of 5? This means x is a 5. Let's plug in a 5. Is it this piece? No. This piece? No, because it's less than 5. This piece? Yes, because it's greater than or equal to 5. So we'll work that out real quick. We have the absolute value of x, not x, sorry, 5 minus 8. And then that means we have the negative absolute value. 5 minus 8 is negative 3. And then we have negative, the absolute value of negative 3 is 3. So this is negative 3. Now, before I go to the next one, let me show you on the graph. X is negative 1, y is negative 4. So if you come out here on the graph, this is going all the way out to negative 9. So if we come out about negative 1 and go down, you can see that right there is where that point is. Now the scale here is pretty big, counting by 20, so you can kind of get an idea. How about 5? If we go out to x equals 5, then you'd see this value right there, that is the negative 3. That's how this works. So negative 2.5, where's that going to be? Well, let's see. Is x less than negative 3? No. Negative 2.5 is not less than negative 3. And it is not more than negative 2. So that means negative 2.5 actually does not exist in this function. It's not part of the domain because it's outside any of our what we could call parameters here. It's outside the domain restrictions that we're given. So that means there's a little gap right in here where negative 2.5 is, and there is no graph. All right, so that's how you do the evaluating of these piecewise functions. Second, now we're going to graph them. So let's start off with this first piece. Don't even worry about the x is less than or equal to negative 2. Let's just graph this first piece, negative x minus 3. So let's see here. We're going to go down to the 1, 2, 3 y-intercept, and then we're going to sketch a graph where the slope is negative 1. So I'll put some other dots here and some dots here. And just kind of think, and by the way, you should be using a pencil. If you're using a pen, this is not going to work out for you because you have to get rid of some of this. We're going to erase it. So do this lightly, very lightly. The thing I'm drawing, just kind of barely sketch with your pencil. Make it very, very light. Okay, so this is our first piece. Now this parameter says that the domain can only be less than or equal to negative 2. So if in fact, I'm going to have some little animation here. I'm going to have a window come up here. Now, if you'll look, we're only looking at this boundary of negative 2, which is going to be right here, and then you're only looking left of that. So that's clear. This is where the graph should exist. So what we'll do here is let's go over to negative 2 and put a dot here that's filled in, and we need to get rid of the rest. So erase everything else. And so the way we start off really learning how to do these is to think about the entire graph, but then this is the window in which it's only showing up. It only exists when x is less than negative 2. It's a filled in circle because x is less than or equal to. All right, now let's do this one. 4. Well, what does that mean? It means y equals 4. Y equals 4 is just a flat line, a horizontal line, way up here. 1, 2, 3, 4, right up here. Okay, so again, remember you want to use, I won't put arrows on that. You want to use a pencil very lightly. If I knew how to draw straight with this thing, you want to use a pencil that's very light, and then look at the window. So let's pull up the window here. You're only looking between negative 2, which is right here, and 1, which is right here. So between those two numbers, and so we can erase everything else. So we're going to erase to negative 2, erase everything that's past the number 1, and then is it open or closed? On the left side here, it is an open circle, and then let's try and make that more on the line y was 4, and then the 1 is a closed circle because it's or equal to. Alright, so there's our second piece, and then our third piece. 2x minus 5. So again, use your pencil, do this light. I'm going to go down here. 1, 2, 3, 4, 5. Put a dot. Sketch my line. Up 2 over 1. Up 2 over 1. Now, I can see it's only going to be x is greater than 1, so I only need to... I'm having a hard time with this. Let me do that line again. There we go. Something like that. And x is greater than 1, so if we look at the window is from 1 and on, so this is going to be our open circle. Let me erase everything that we don't need. And then right there at x is 1, we can have an open circle right there, and the graph takes off from there. Okay, that's how we do these. You want to think about what does the entire graph look like, and then get rid of anything that's not needed. Let's do another example that's beyond just lines. We're now going to do some parabolas here, and then this one will be a line. So let's start off with the vertex. Negative 1, 7. Negative 1, up 7, 1, 2, 3, 4, 5. Oops, 1, 2, 3, 4, 5, 6, 7, way up here. And we're going to graph. Remember, you should be doing this lightly with a pencil. Just sketch it light. Let's get some other points. Here's our other points, here and here. I'm using what's called the 1, 3, 5 method. I'm going to go down 1, and then I'm going to go down 1, 2, 3. And I'll reflect that point over here. And then I could go down another 5. 1, 2, 3, 4, 5. That's how I'm doing this fast. You could also plug in some coordinate points to be able to figure out where this parabola is. Alright, so if I'm sketching this whole thing, you'd be doing something like this. Going down. Now we only want this graph to exist when x is less than 2. So we have to come out here to this x equals 2 value, and then it's only going to exist left of that. So everything else, let's erase all this stuff. We can erase everything that is to the right of that. Now, is this exactly on that line? Let's see, x is less than 2, so it's going to be open. Well, we could figure out exactly where it is by plugging in a 2. Let's figure out where that hole is. 2 plus 1 is 3. 3 squared is 9. So I've got a 9, and then there's a minus in front, plus 7. What is that? That's going to equal negative 2. So if I were to graph this correctly, oh, I did have that point down there earlier. That's where it should be going. So I kind of messed up on my graph a little bit there. Let's plug that point back in, and it's going to that point there. Okay? And there's the left piece that's less than 2. Now we have a jump. We're going to go all the way up to x is greater than 4. Let's graph it first. Negative 1/3 x. Very lightly with your pencil, we're going to have a y-intercept of 0 right here. And then we're going to have a negative 1/3. So we're going to go down 1, 1, 2, 3, and over. And then down 1 and 1, 2, 3, over. Okay, so your line is going to look something like this. If I connected the whole thing, I could, but I already know that x can only be greater than 4. So I'm going to go out here, 1, 2, 3, 4, and it's going to be an open circle right there. So let's try to make this exact. Where exactly is that hole? Well, let's figure out where h of 4 is. H of 4 is, let's plug it into the line, and you get negative 4/3. So about negative 1 1/3, which looks pretty close to what that is. Let's clean that up and make it an obvious open circle. So 1, 2, 3, 4, and about 1/3. So something like that. Okay, there you go. There's that piece. Next up, you're trying one on your own. So go ahead and pause this video now, which is important. Please don't skip this. Pause, try this one on your own, and I will have your answers show up here so you can see if you did it right. And here's our answer. You got this parabola over here that had a vertex at negative 3, negative 5. You've got this line at y equals negative 1. That's our second piece here. And then our last piece, when x is greater than 2, be careful there, it jumps from 1 to 2. So that's why there's a gap here. And so you have there that vertex at 4, positive 4, because that with a absolute value graph opening down. All right, so hopefully you got that one okay. Pause here and look at that one and sketch that out if you don't have that correct in your notes. Number 5. Now, here's the hard stuff. We're going to write an equation of this graph. So let's come up with, first, how many pieces are to this thing? I have 1, 2 pieces. So when you draw your bracket, this weird little squiggly bracket, drop big enough to contain 2 pieces. So let's take the left piece here. What is the equation of this line? You have to think about what it would look like if you just kept going and going and going and going. And so this can be kind of challenging. Let's looks like it's a y-intercept of 2, which it should be. If you're not sure, we've got we got a dot here, and we have a dot here. So you could always think about these coordinate points and figure out the exact slope. So the slope is going to be 1/2 is the slope, but it is negative. Be careful about that. A lot of times kids see, there's an arrow that goes up, so it's positive slope. No. Think about the entire line. What would the entire line be doing? Okay, now it looks like it's going through the number 2, but let's verify and just make sure. So I'm going to plug in a point here about this point, negative 2, 3. So I'm going to use a slope of negative 1/2 and a coordinate point of negative 2, 3, just to make sure that I get this line correct. So y minus 3 equals negative 1/2 times that by x plus 2. And then let's see here, y minus 3 equals negative 1/2 x minus 1, negative 1/2 plus 1. Add the 3 and you get 2. So y equals negative 1/2 x plus 2. All right. So I'm going to write that down on this. Negative 1/2 x plus 2. This is not necessary. You don't actually have to write out the equation next to the piece, but I'm just doing that because sometimes you might find it helpful. So y equals negative 1/2 x plus 2, comma. What's our domain restriction? It's the x values that are less than or equal to, see this? all of the x values to the left of -1. So I put a -1 right here. Now let's do the second piece. This is a quadratic. So let's see here. It's opening up. That's simple enough. So a quantity squared. It's just going up 1. When we go over 1, we go up 1. So the a is a nice, easy 1. X, I'm moving right, so we do the opposite. -2. And then minus, because we're shifted down, 3. Quantity x minus 2 squared minus 3 when x is, so think about this, where does it start? The x value here is a 0, so it's x is greater than 0. Ooh, there's your pieces. 2 pieces with all the graphs. This is the final answer I'm looking for. Don't close it. There's no closing the bracket here. Don't do that. It's just open right there. All right, and now the last thing, and then we're done. Hey, I have no like cool, funny things for this one because I wore out my creativity in the last one. Those surfers just really took too long. Okay, so sorry about that, but yeah, you're just learning math right now. Number 6. This is great practice for calculus. Every year, kids who go into calculus are so confused by these. So let's get this down a little bit now because really, you shouldn't have to be confused by this in calculus. Let's take care of it in pre-calculus. We're trying to figure out if these things connect. Now let's talk about that for just a second. I'm not going to draw a graph of these, but if I had a piece here and it was an open circle and another piece here and this was a closed circle, those are obviously not continuous. Okay, but if I could take this thing and shift it up like that and put it right there, then it would be continuous. So what does that mean? If the x values, watch this, if the x value here, let's say that x value is, let's just call it a 2, and this y value is a 3, and this y value is a 1. I'm making stuff up right here. Obviously, it's not continuous, but if both these x values are 2, I could make it continuous if the y values were both the same thing. So that's what we're looking at on these pieces. How do you know if it's continuous or not? If I take an x value, in this case it would be -1, because that's where the 2 pieces are meeting each other. If the x value is -1 and the y values are the same, then they're continuous. So all you have to do is this. This is how easy this is. Plug in a -1 to the first piece. Minus -1 plus 1. And then let's see if that equals. Now we plug a -1 into the second piece. So -1 cubed.
I'll do a plus 6 -1 squared. I know I'm running out of room here. Plus 12 times -1. Whoa, I'm really going over to the other problem. Plus 11. Hopefully you can squeeze this in somewhere in your notes. Sorry. Now, let's get rid of this. Ooh, it's just in the way. And keep going here. Squared, that's a 2. Plus 1. Plus 1. There's my equal sign. This is a -1 because it's cubed. This is positive because we're squaring it, so it's plus 6. This is a -1. I can barely read my writing, so that makes this minus 12, and then plus 11. So 2 plus 1 plus 1, 4 equals, let's see, 6. What is this? That's a 5. Minus 12 is -7. -7 plus 11 is also 4.
Ding, ding, ding. It worked. So that is showing your work. So be careful on this in any mastery checks or tests or anything. It's showing your work that leads to our conclusion that both pieces equal each other at that x value. So go ahead and try out number 7. I'll have to write my answer here because I didn't leave myself enough room. Pause now and I'll get your answer up here in just a sec. All right, you can see from my work what I came up with was that these are not continuous. So, I forgot to say that. This one, yes, it is continuous. And then this one, the 7th problem here is not continuous. So just to make sure we've answered our question. That's answering it. That's showing the work. Why not? Okay, we are done. Hey, one last thing before you move on and start doing your practice. I'm going to put down below, look down there. There's going to be an optional video. You don't have to watch this, but there's actually a way your calculator can do piecewise functions. So I'm going to show you just one example from our notes of how you can plug it into your calculator. It's just real fast. Hopefully it's just a few minutes long. So you might find that interesting. Not required, but again, it might help you out in some of the graphs that you're trying to make to help you see what it's looking like.